we're going to talk about conditionals. Conditionals are a good thing. So, first of all, when we're talking about conditionals, this right here, we would read this. This says, if P, then Q. And it says to underline the hypothesis and circle the conclusion. We start with the hypothesis, we end with the conclusion. All right? So the hypothesis is the if part, and the conclusion is the then part. So if two angles are a linear pair, then they are adjacent. So if two angles are a linear pair, then they are adjacent. Okay, so the conclusion of angles being a linear pair is that they're adjacent. That's what this is saying. Don't know if it's true or not, but that's what this is saying. The basketball team will go to regional championship game if they win this week's game. So where's the if at? It's at the end. So what are we saying really? If they win this week's game, the basketball team will go to the regional championship game. Perfect. See how sometimes it can be at the end? You just got to look for that if. All right, so now I'm going to go through this table. Now this table may be a little confusing at first, but I want to walk you through all the different kind of conditionals there are. So the original conditional is if P then Q. The converse of that just means flip the P and Q, so it's if Q then P. It's kind of the backward statement. Then there's the inverse, which just takes the conditional and inverts it, so it becomes not P, if not P, then not Q. You usually don't get to use that one because it's kind of mean, right? And then we got the contrapositive. The contrapositive is applying both the converse and the inverse. So we're mixing it up. And it's going to be not if not Q, then not P. To P or not to P? That is the question, right? Okay, so now we're going to talk about when things are true. Because part of being a conditional, if you read the definition back there, it says that a conditional is false only when the premise is true and the conclusion is false. The premise, by the way, is the hypothesis. Hypothesis and premise, same deal. So if this hypothesis, the opening part is true, but the conclusion is false, then it's going to make the whole statement false. But let's go through truth values. So first of all, we're going to start off with true, true. If both are true, then we have an if true, then true statement, so this is true. In fact, it's going to be true across the board. All of them are going to be true. If we have a true false, where the P is true but the Q is a false statement, then what are we going to have? We're going to have that if P then Q, right? If true, then false. Remember, we can't end with a false. That would make it false. If we turn it around, it goes if false then true. That would be true. Then it's going to say not P, not Q. So that says, if false, then true. Well, remember, the only time a conditional is false is if it starts with a true statement and ends with a false statement. This one starts with a false and ends with a true, so it's still true. And then last but not least, now we're going to flip it back around. We have not Q and not P. So now we're saying not Q. So if true, then not P would be false. So if true then false, that means the premise is true, the conclusion is false, so this would be false. Now let's talk if we switched around, false, true. Just going to change it up a little bit. Our if P then Q is now going to be true. Why is that? Because now we have a situation where we're starting off with a false, but we're ending with a true, and that's okay. We can't start off with a true and end with a false, but we can start with a false and end with a true. Think of it like this. Let's say a false statement is, if I don't go to the store, then I am not in the store. Well, that's true. The false part was, I didn't go to the store, right? But if I still... but then I'm not in the store, that's a true statement. I can start with a false and end with a true, but I can't start with a true. If I am in the store, then I am not in the store. That doesn't work. I can't start with a true statement and then end with a false statement. That's not a true deal. So it's a little bit to wrap your head around. That's why we make this table, just to kind of help you go, all right, here's where it goes. So again, this one would be Q then P. So this is if true, then false. That is a false. This one is not P, then not Q. Well, not P would be if true, then not Q, which is false. So that would make it false because it starts true and ends false. And then the last one is not Q, then not P. Let's see, not Q would be false, and then with a not P is true. We can, as long as we end with a true, we're good to go. So let's see it, true. Boosh. Now the last two is false, false, and believe it or not, this comes out amazingly because false, false is true. If false, then false, that's true. If I'm not in the store, then or if I'm not going to the store, then I'm not in the store. That's true. And it's saying backwards, true. And it's saying this direction, true. And saying this direction, true. Awesome. So, a lot of stuff going on there. This truth table is going to help us. We'll talk about it as time goes on. But for now, just go ahead and get that filled in. Good stuff. All right, let's look at it. It is Independence Day is our first statement. And our Q statement is fireworks will be set off in Springfield. Using the above, we want to write a conditional statement. So, if P, then Q, right? So, for our conditional statement, it is if P, then Q. So let's write that down. If it is Independence Day, then, what's our Q? Fireworks will be set off in Springfield. That's our OG statement. And now what does our next part want us to do? It wants us to go a little deeper, and it wants us to write the converse, inverse, and contrapositive, which is the converse where we switch their order. The inverse is where we stay with the same order of if P then Q, but we negate them. And then our last is our contrapositive, which is where we flip the order and we negate them. So let's do this. Now I'm going to separate this into thirds as best I can, just so we have room to write the sentences. So the converse, remember what the converse is. I'm going to do the converse first. And that is that if Q, then P. So let's just write that down. So Q first. If fireworks will be set off in Springfield. So if fireworks will be set off in Springfield. Then I know lots of writing. Then what? Then it is Independence Day. Awesome. So let that sink in. The converse was if Q, then B. So now we just switched it up. We said if fireworks will be set off in Springfield, then it is Independence Day. We flipped it around. Now let's go on to the inverse, which means we keep it in the if P then Q order, except we negate each one. So I'm going to say if it is not Independence Day, then fireworks will not be set off in Springfield. Awesome. Oh, I gotta go to the other line. Field. It is Springfield, right? Yeah, field. That's the inverse. So this time we left it in the right order, but we just made it not. Wait, yeah, will not be set off. See, I got the two nots going on there. I thought I missed that not for a second. And then the last one we have is called the contrapositive. So this inverse, by the way, was if or not P, then not Q. Okay. The last one is the contrapositive. And let me show you how this one works. This one is if not Q, then not P. Okay, if not Q, then not P. It's kind of hard to see that these are my squiggly lines. Squiggly, make them a little extra squiggly. So let's do it. Not Q. If fireworks will not be set off in Springfield. So if fireworks will not be set off in Springfield, then it is not Independence Day. Independence Day. Okay, so those are the converse, inverse, and contrapositive. Again, the contrapositive is we flip it and negate it, right? So the converse, we just flip it. The inverse, we don't flip it, we just negate it. But for the contrapositive, we negate it and we flip it. Perfect. All right, for this last one here, just about done. Let's take a look at our next slide. You see where I give you the words in the symbols box? I want you to take a minute. You're going to pause this once it loads up. And we're going to talk just briefly about a biconditional. Let's get into it. So biconditional statement is the conjunction of a conditional and its converse. So conjunction is the and. So if P then Q and if Q then P. Now, conjunction, the only way it's true is if both are true. So if your conditional statement is true going forwards and true coming backwards, then we can write what's called a biconditional statement, which looks kind of like the if P then Q, but notice it's a double-sided arrow, and the way you read it is P if and only if Q. So go ahead, take a minute, pause this, write that down, because we're going to move right on to our last item of the day. Boom, let's do this. Maybe. Okay, let's just go up here and look. There we go. All that's lined up. We see the biconditional statement in words and in symbols. And we see now, consider the following. P, lines are parallel. Q, they have the same slopes and different y-intercepts. Write the conditional and converse and determine the truth value. Okay? So the conditional is if P then Q. So if the lines are parallel, don't forget that's the symbol for parallel, then they have same slope, and different y-intercepts. So different y-intercepts. Notice I shorten things up a little bit. You can do that as well. So this is for if P then Q. Now it says we want the converse. So we got to write the if Q then P. I'm going to write them down, then we're going to talk about the truth values of each one. So if Q then P. All right. If they have the same slopes and different y-intercepts, they have same slopes and different y-intercepts, then the lines are parallel. Which again, right, parallel shorthand. Okay, let's talk about this. So the first one, if the lines are parallel, so we're going to assume they're parallel. If the lines are parallel, then they have the same slope and different y-intercepts. That's the definition of parallel. Their slopes have to be the same. They have different start values so that they're not crossing. Boom. This is true. This one has to be true, though, to write a biconditional. If they have the same slopes and different y-intercepts, we have two lines, same exact slopes, different y-intercepts, so they're starting at different spots on the x-y axis. And it says, if that's true, then the lines are parallel. Guess what? That's also true. So if P then Q is true, and if Q then P is true, it's true both ways, then we're told we can rewrite this. And when we rewrite it, we're going to say P if and only if Q. All right? And what's the biconditional that we can write? We can say, remember, it looks like this. It's for good backwards and it's good forwards. Okay? So we're going to say lines are parallel if and only if. That's the new word we're using for the biconditional. Lines are parallel if and only if they have the same slopes and different y-intercepts. Awesome. I know it's kind of a heady lesson. It's going through a lot of memory. It's just like going, all right, if this, then that, true. Use your truth table to really help you with this on this lesson. With that said, peace out.